Section 3.4 in Algebra 1, we're dealing with variables on both sides. So basically, you're going to be working with the equations you worked in the last section, but you were lucky enough the last section that all the variables we're looking for are isolated to one side. Now, all the rules still apply to this section. It's just our first goal before isolating x is to get all the x's on one side of the equal sign so that we can just be dealing with one variable. Okay? So for example, we have 6x plus 22 equals negative 3x plus 31. Well, I have a negative 3x on this side and I have a 6x. Somehow, I have to get them all to one side. And again, I can do anything that I want as long as what I do to one side, I do to the other. Okay? So let's look at this negative 3x. I want to move it to 6x, but it's being subtracted on this side. So in order to do that, I'm going to keep the equation balanced, but also do the opposite. Because if I add 3x to this side, it cancels. Negative 3x plus 3x cancels out. But I also have to do it to this side. I'm going to do it to the 6x. I'm going to add 6x and 3x because x is not a common term with 22. So 6x plus 3x gives us 9x plus 22 equals what's left? 31. Right? Now we've moved all the x's to one side and it's just the things that you've dealt with last section. We're going to get rid of x's friends starting from the furthest out. Well, the furthest out is positive 22. Okay? When I'm doing positive 22, I need to then do the opposite, which is negative 22. That cancels this out. Negative 22. So I end up with 9x equals 9. Well, x still has a friend, and that friend happens to be 9. So, and it's being multiplied. So the opposite of multiplying 9 by x is to divide. So I'm going to divide by 9. This cancels out. I end up with x equals 1. And that's my answer. Alright? Okay, so let's try this on another problem. I have a negative 12w on this side and then 6w on this side. Now, I can bring the 6w on this side, but then I would just have a 0 on this side. I want to be able to have the w's on the variables on one side, everything else on the other. So I'm going to get rid of this negative 12w and bring it to this side. Well, it's being subtracted, so the opposite is addition. So I'm going to add 12w to both sides. I'm going to bring this down. I end up with 64 equals 18w. Okay? Now, what I do next is I need to get rid of that 18 that's connected to, I need to get rid of that 18 that's connected to the w. And I do that by doing the opposite. If this is being divided, if this is being multiplied, I'm going to divide. Divide. Okay? I end up with 64 over w. Well, 64 divided by w, my calculator tells me, is a decimal, 3.55. So it's 3.56. Alright? Let's try the next one. Well, the next two have parentheses in it. So we have to make sure to pay attention to those parentheses. So let's start with that one first. Okay? When we have parentheses, we're going to take the outside number and we're going to distribute it in. So I have a 5 here. I'm going to distribute it to my x, giving me a 5x. I'm going to have this 5 and distribute it to a positive 3, giving me a positive 15. And then I'm going to bring everything down. Okay? Now, I'm going to go ahead and subtract the opposite. Subtract 15 from both sides. I end up with 5x equals 5x, right? Because if I want to get rid of 15 here, I have to subtract it. Well, this also has a positive 15, so if I subtract from there, these both cancel out, and I end up with 5x equals 5x. When I end up with the exact same thing on both sides of the equal sign, this is called an identity. The reason why it's called an identity is because no matter what I put in for x, they will always be equal, because it's being done the same thing on both sides. So anytime I have the same equation, I can stop and I can just say that, oh, it's an identity, because I can put any number in for x. So let's try the next one. It's the same thing. I'm going to take 5 and I'm going to give it to each one. So 5x, and I'm going to give it to positive 3 equals 5x plus 3. Alright? So let's start with subtracting 15. Well, let's get rid of this x right here. Okay? I want to not get rid of it. I want to bring all the x's to one side, just like I did in the prior. So if this being attached by a positive 5x, I'm going to subtract 5x from both sides. Okay? So 5x minus 5x cancels out, and I end up with just 3. Now this 5x unfortunately also cancels out, so I got rid of all my x's and I end up with 15 equals 3. Now think about this. When in math will you end up with 15 equals 3? Well, because 15 will never equal 3, and this is not true, and I got rid of all of my x's, my only way out is to say no solution. Because there's no way I'm going to get 15 equals 3 and I have no x's to work with. Alright? So these are variables on both sides, but if I end up with the same exact thing on both sides, it's called an identity. If I end up with numbers with no variables, then I end up with no solution. Alright? Try page 154, number 14, and don't forget your vocabulary, and I'll see you in class.